These are the two maps. If you drag in a different one, if I drag in this one into the thing, I don't want to do it because it, well, I'll have to put this one back in again. Let's do it. So you can see we've got a very different texture on the water now here. Maybe you like that, maybe you don't. I feel it's got too much white in that normal map. It makes it look very turbulent. It's not quite what I want. You could put this one in, see what that looks like. I don't think that one's quite as nice. It's all about whatever you find and think is better. These are ones I just found off the internet and I thought they work quite nicely together. So the shader graph looks quite busy, but essentially my understanding of the shader graph is that you have sort of two sections. You've got this this stuff up the top here that I'm unboxing, and that is all feeding into this vertex phase of the render pipeline process. This happens first, so in the rendering pipeline unit that Unity is using, the universal render pipeline, it calls out at this stage, this first stage, to our shader graphs that we have to implement this section that is feeding into here, which gives us opportunity to manipulate the apparent position of the vertices of those objects that are being shaded by this graph. So we can, for example, move the position of vertices, or their apparent position, their position as they will be rendered, change their tangents, change their normals in some way. So that's obviously useful for making things like waves, and that's what we're doing here. So we have a time related, we have a multiplier, so we can speed the effect, increase the amount of effect this has. But essentially we've got time going in that's affecting our offset. We're changing our offset position of a gradient noise map, which is choosing where we are in the map, and then the outcome of that. So that's why that's moving, is because we've got it's linked to time. As time progresses, we're moving our position in the map. The sample position is then being that is being multiplied up and being fed into our this says RGB, but remember this could equally be X, Y, Z. In this case it is, because we're feeding position in here, splitting it into effectively X, Y, Z. We're just carrying the X and Z, the lateral positions through as they are. So that's the lateral positions of the vertices in the water plane that we're shading with this shader graph, but we're not bringing through the Y or the vertical. Instead we're taking that from the noise map, and we then have effectively got waves being introduced, and that's being fed out as our new updated vertex positions. Then in the render pipeline process, Unity does its other stuff, whatever it has to do, before reaching the stuff where it's going to actually colorize the pixels and everything on the screen. And again, it calls out to our shader graph to give us opportunity to manipulate the outcome. So all this bottom stuff that's feeding in here affects that stage of the render pipeline, and we're affecting the base color of the pixels, or the material, shall I say, of our material base color, and the normal map for the material, and the smoothness and the emissions, and all these things you're familiar with in materials are being manipulated effectively in real time to produce a material that has these properties updating or changing potentially with every frame. So huge amount of versatility here. So we're affecting the transparency. That's coming through from our color, shallow color here, and our deep color, which we have somewhere else. Where's our deep color? I'm not sure. Maybe it's just our shallow color coming through. Certainly we're lerping between our right, yes. It was over the top of each other. So yeah, we're lerping between the two colours, and then the resulting interpolation of those colours, we're splitting it into the RGB alpha, and we're using the alpha, taking it straight through and using that in the final material colour, and the output of the two these two colours is going through as the base colour for our plane. Great, we've set the base colour as being an interpolation of these. But how do we choose what our interpolation should be based on? Well, it's the interpolation amount or percent from one to the other is decided by the maths here and our own amplification number if we want to increase or decrease the effect of what we're doing in our maths, and clamping it between 0 and 1. For our interpolation, we want to interpolate between 0 and 100% of either one of these, nothing more. So the maths, I don't fully understand quite why we're using the camera far plane as effectively a constant factor that is being used as our multiplier, but we are. So maybe that's what gives us the sort of iridescence or change to our. You can't see it so well here, but the color actually varies with the viewing angle and proximity to the camera. So possibly the far plane is affecting that, but I think it's someone has figured out that this works nicely in terms of taking the depth of the scene, multiplying it by the far plane of the camera, and subtracting from that the screen position. And this bit is a bit I know least amount at the moment. I don't know what this means. Is this a two-dimensional position of the screen? I assume it's so. In which case, what is this X, Y, Z, RGBA about? I need to look into this because I don't understand it, but it's something to do with the screen position, the scene depth, and the camera far plane, all being kind of combined, being fed in to affect how much we're blending between these two colors. So essentially that means for the shallow areas we use more shallow, and for the deeper areas we use more depth, cleverly worked out by that maths somehow. And the effect of that blend we control with our sliders here, depth strength and depth parameter. So if I change that, you can see the effect that maths is having on our transition from one color to the other. And I think I had that at 0.24, which is the way I like it. That's that. Then the other factor, so that's affecting the base color. We've got smoothness up at 100% at the moment. The other thing we're affecting is the alpha, so that's just coming through from whatever we've set these to, so it's not being manipulated in time. But what is being manipulated in time is the normal maps. So we've got two normal maps. I've got main normals and secondary normals, and we've got a speed, and notice there's a negative number on this one. So these are being combined, and the normal maps are what give it the appearance of these moving waves that are so compelling in terms of making us think that that's water. So that part of the graph is here. we have we're using time as our main input, and it's being we're scaling it to be something handy, and we're using that as a tiling position, just like we used before in the moving the vertexes of the mesh. So we change our sample point of the normal texture, and so our main normal texture here, and the speed of the speed factor, where's that coming in? Here, main normal speed, there, 123. So we're dividing time by 123 and using that as our offset position in our texture map here, and then that sample is just being going through here, and we're going to combine it with this texture map, which is what this addition is about. So we do exactly the same on this one. We take time, but in this case I've actually changed it to sine time so that we get a sort of an oscillating behavior on this second map, which I like. It gives it that sense of, feels like a bit of a tidal movement. That kind of, I think it goes well with the way we're moving the mesh vertices for the waves. So that was a little tweak I made. Secondary normal speed, so we're going in the opposite direction. So minus 67 is plus 123. So we're going in a different direction to sample this map, and we sample that, and the point we're sampling it out at we add two normal maps together, and we blend them according to this previous algorithm about the depth. That was effectively working out the depth of the water, or giving a surrogate for the depth of water, and we're applying that for the strength of the normal map, and that comes out here. So that's roughly how it works. Maybe that was too much detail, and that's my first go with the water shader, and I'm really pleased with the result, especially around sunset. Sun up and sun down looks really nice. The rest of the time, oh, I've gone under the surface, so you can't see the water's edge anymore. Have to come out. This game is all about walking around very slow and tediously for the main part at this stage, so getting about is quite slow. Anyway, quite pleased with this. It does now look like water rather than just colorized valley. So I'm going to leave it here for now, and then press on to the next aspect of the game to try and bring some vegetation to this fairly barren landscape.